Hello there. Uh, I'm Mr. Panda. I don't know where Mr. Lee went. Uh, Let me go look for him. I guess I can teach you about circles. How's that sound? Oh, wait, I think I hear him.
Oh, hey, Mr. Panda. Thank you. Well, anyways, welcome back. Um, Mr. Panda could teach you about circles. I guess he knows a lot. But don't worry, I'm here. But hopefully you were able to watch the first video from this week. So about your central angles and the arc measures. If you haven't, then please take a look at that video, watch through it, take some notes. Because I think it's very important to understand this next video. But if you do understand that, then we are ready to move on. So let's go ahead and take a look here. So recall that in the last video, we determined the measures of angles and arcs in our circles. So hopefully that is good to go. Now in this video, we are going to be looking at determining the relationship between central angles, remember that was from last video, and then inscribed angles and their intercepted arcs. Okay, so we got to talk about what is an inscribed angle and what are intercepted arcs. So again, let's just start with some vocabulary. Recall central angles. Those are your angles with a vertex at the center and radii as sides. So again, hence central angle, vertex is at the center here. So that would be this guy. We have radii as sides, vertex at the center. Now recall that that was equal to the measure of that arc. So if I look at this picture and I say this angle, let's call it 110 degrees, well then the measure of this arc is also 110 degrees. Okay, so key facts from last video. Now what we're adding to this is our inscribed angles. Now what an inscribed angle is an angle with a vertex on the circle and chords as sides. Now, chords, it's a vocab word we'll talk about in the next video, but it's just a segment that connects 2 points on your circle. Okay, so now, key difference here is our vertex. It is on the circle. It's no longer at the center. Okay, then we have our chords here, our two sides of our angle, and that is our inscribed angle. Now, if you look at our two pictures, okay, both of our angles, they are eating an arc. Okay, I like to think they're eating an arc here. That arc is what we call the intercepted arc. So the arc with endpoints on two sides of an angle. Okay, so if I look at these guys, this up here is our intercepted arc, and then this down here is our intercepted arc. Now, the difference between a central angle and an inscribed angle. So let's say that this is, let's say that looks like a 40-degree angle. Okay. The measure of this intercepted arc is not 40 degrees. It is actually 80 degrees. So it is double the measure of that inscribed angle. So times 2. So if I want to jot down a quick note here, inscribed angles, it is equal to half of the intercepted arc. So just keep that in mind, whereas this guy, our central angle, is equal to the measure of our intercepted arc. Okay, so just two things to keep in mind there. All right, so now let's take a look at the relationship between the two. So central angles and inscribed angles. Well, if we know how both of them relate to that intercepted arc, well, then we can find a relationship between the two. So here I want to determine the measure of the central angle, angle B, and the inscribed angle, angle D, and then figure out, okay, what do we notice? So if I look at this picture here, okay, I have our central angle and our intercepted arc. Our measure of this intercepted arc is 100. Well, recall that those are equal, so this is 100 degrees. Okay. Now, we can now look at the inscribed angle, angle D, same intercepted arc. So they both have the same arc measure, but remember that I take this guy and I cut it in half. Okay, so then our angle D would be 50 degrees. So then how do angle D and angle B relate to each other? Well, the measure of angle D is equal to 1/2 the measure of angle B. And that will always be the case. So the measure of the inscribed angle is always going to be half of the measure of that central angle, as long as they have the same intercepted arc. So as long as they're eating the same arc, well, then their measures are 1 to 2. Okay? So knowing that key fact, let's take a look at a couple special just key points that we need to know. Okay, so what we just came up with, the measure of a central angle is equal to the measure of its intercepted arc. The measure of an inscribed angle is half the measure of its intercepted arc. And then if a central angle and an inscribed angle intercept the same arc, then the measure of the inscribed angle is half the measure of the central angle. Okay, and you can look at the previous slides to look at some numbers there. All right, so a couple specific examples that we can also look at. Okay? So what if two inscribed angles intercept the same arc? So I have this green angle and this orange angle here. Now, if you notice, they have the same endpoints at A and C, so they are intercepting or eating the same arc. Okay, so let's put a number to this. Let's call this 100, okay, just for ease. Well, if I look at angle D here, that's an inscribed angle. Remember, I cut that 100 in half, so then this would be 50 degrees. Okay, so that is angle D. Well, if I do the same thing for angle B, notice it's the same intercepted arc, so then I know it's the same relationship. Okay, I take this number, I cut it in half, so this would also be 50 degrees. Well, what do you notice between the two? Hopefully you see, hey, they're equal, they're congruent to each other. Okay, so what we can say is the measure of angle B is equal to the measure of angle D. And that will always be the case. So if I have, let's say, a pink angle here, if I have from C to here and A, as long as they're the same endpoints, well, that will be the same angle as well. That will be 50 degrees. I could also, let's make a red angle, starting at C over to here, and I complete the angle to A. That is also 50 degrees. So each of those angles, the orange, the pink, the green, the red, those are all congruent to each other. So it's just it's a fun little fact. I think it's some extra information there. All right, let's look at another specific case here. Okay, so what if an inscribed angle intercepts a semicircle? Well, remember, a semicircle is how many degrees? 180. Okay, so it's half of your circle. So in this case, our semicircle that is being intercepted is from A to C or C to A. So we know that is 180 degrees. Well, if I think about, okay, this inscribed angle here, let's go ahead and make this orange, is eating that 180 degree arc. Well, remember, you cut that in half, so you divide by 2. And so what does that mean? This means angle B is a 90 degree angle. Okay? And that's always going to be the case again, because if you have the same endpoints, A and C, well, I can make let's make a green angle here. If I go from C up to here and ended at A, well, that's going to be 90 degrees as well. Or I could make a pink angle, let's say from C up to there, over to A, that's going to be 90 degrees. And let's do one more just to show you. Over to there, and then over to there. That's a 90 degree angle as well. So as long as it's eating a semicircle, 180 degrees, that inscribed angle will be 90 degrees, a right angle. Okay, so just another key fact there. All right, so let's use that and let's look at an example here. So I have some inscribed angles, I see some central angles, I have some arcs. I want to determine these following values. Well, again, just like in the last video, let's just look at the circle and figure out, okay, what can I fill out? Okay, there's a lot of information I know right here. So now there's a lot of stuff in this picture. What I suggest is try to just focus in on a single part. So if I look at this angle, that's 48. Well, I know that that is that guy. So it's an inscribed angle. Remember, the vertex is on the circle. It's not in the center. So how does that relate to this arc DT? Remember, I take that and I multiply by 2. So if I take 48 times 2, that's going to give me a 96-degree arc. Okay. All right, so that's that guy. So now let's look at what other information I have. Well, I have that inscribed angle, 70 degrees. So that gives us that arc. Well, our inscribed angle is 70 degrees, so that arc would measure 140 degrees. Okay. All right, now, those are the only numbers we're given, but let's think about what else we have in this picture. Well, if you notice from D to B, that goes through the center, so we call that a diameter. Remember, that cuts your circle in half, so 180 degrees. So then if I look at this arc here, remember that's a semicircle, that should be 180 degrees. Well, a part of it's 96. So if I want the other part, well, I take away that 96 from 180, and I end up with 84 degrees. So this guy is 84. That's from B to T. Okay. So then let's think, okay, well, I have an 84-degree arc here. Well, what angles go with that? Well, I see a central angle. Now remember, a central angle is equal to the measure of that arc. So this central angle would be 84 degrees. Okay. Well, are there any other angles that go with that arc? Well, if you look endpoints, we have that angle, which is an inscribed angle. So it's going to be half of that arc. So then I take 84, I divide by 2, that gives me 42 degrees. Okay. All right, so then there's nothing else that I can tell from that arc. So then let's look at, okay, is there anything else that I can find? One other thing that I see here is because I had a semicircle or a diameter, well, I know that, hey, that should be 90 degrees. That's from our previous slide. Well, if I add up 42 plus 48, what does that give us? That gives us 90 degrees. Okay? Which then would actually allow us to find this angle because I have a triangle here. And if you recall from earlier in the year, our triangle angle sum theorem says all of those angles should add up to 180. So I take those away and I end up with 20 degrees. Okay. And okay, lastly, now that I know that angle, that inscribed angle, what does that allow us to find here? Well, I have an inscribed angle, the arc, I know I double, so that gives me 40 degrees, which I could verify because that's a semicircle. So then these two should add up to 180, which they do. All right, so now let's think about, all right, what is the problem actually asking us to find? So the measure of angle DAB, DAB, okay, that is that angle there. So then I know, hey, that's our inscribed semicircle, so that was our 90 degrees. Okay? Then the measure of arc AB, so that would be 140. The measure of angle BOT, that is our central angle, that is our 84. The measure of arc AT, well, let's think about that. So that's from A to T. Now, one key point here. How do I know that it's not that guy? Okay, well, the pink, that is your major arc. And if you remember from last video, we would need 3 letters to name that. So I would need to name it ABT. Since it's only AT, then you go the shortest distance, your minor arc. So I know from A over to T. Okay, well, recall that I could just add those 2 arc measures up and I end up with 136 degrees. And then lastly, ATB. Okay, since 3 letters, that is our major arc. So from A through T to B. So I add all of those up and I end up with 220. Okay. So again, a lot of pieces in this single picture. Try to boil it down to just the inscribed angle that you're looking at or the central angle that you're looking at. Fill out as much as you can, and then you can answer what it's asking for. Okay, so let's look at one more specific example here. Okay. So an inscribed quadrilateral, it's made up of multiple inscribed angles. What it means to be inscribed is all 4 vertices are on your circle. All right, so we have this quadrilateral here. I want to know, do we have a relationship between these 2 angles, angle B and angle D? Okay, well, if you notice here, okay, angle B, let's make this blue. That's an inscribed angle, and the arc here is that guy. Okay, and we know, okay, that is half of that arc. So keep that in mind. Let's look at angle D. So angle D is this inscribed angle here. The intercepted arc is that guy, right? Which we know it's half of that intercepted arc. Well, if you look at the red and the blue now, it's a complete circle. Well, the measure of a complete circle is 360 degrees. Okay, so if I know these angles, that angle there and that angle there are half of those arcs, well, if the arcs add up to 360, what is half of 360? We know that would be 180. Okay, so what does that allow us to say? It says angle B and angle D are, what's our vocab word? Are supplementary. Okay, and that's always going to be the case. Okay, so the opposite angles in an inscribed quadrilateral are always going to be supplementary. Okay, which in numbers terms, that means the measure of angle B plus the measure of angle D is equal to 180 degrees. Okay. Now I could also say the same thing about angle A and angle C. So if I look at this angle here and this angle here, I could do the same proof and I will know that angle A plus angle C, that's going to give you 180 degrees as well. Okay, so just keep that in mind. And let's take a look at an example of that. So it says Luca is designing a stained glass ornament. Determine the value of X here. So if I look at this circle ornament, okay, I have an inscribed quadrilateral. Remember, all 4 vertices are on our circle. And so that tells us that these opposite angles are supplementary. So they're not equal, but I do know they add up to 180. So what does that allow me to do? Well, I could take those 2 measures. I could say 3x minus 16 plus x minus 4 is equal to 180. Okay. Now I combine my like terms. I have 4x minus 20 equals 180. Add the 20, so 4x equals 200. Divide by 4, and I end up with 50. So that is our value of x. Now, if it asked us for what are the angles, I could take that. I could plug it in. But again, the key here is I know the opposite angles are supplementary. They add up to 180 degrees. All right. So again, a lot of stuff in there. Our key points here. I would say just make sure you understand. Let's go ahead this guy. Okay, so the measure of a central angle is equal to the measure of the intercepted arc. The measure of an inscribed angle is half the measure of the intercepted arc. And if they share the same intercepted arc, the inscribed angle is half the measure of the central angle. I think those are your big key points. If you know those, then those other slides that we showed you, I think you could kind of come up with if you needed to. Okay? All right, so again, if that makes sense, please, you can jump on to the next video. If you are a little confused there, we can come up with some extra examples. We can show you some more, but you gotta reach out to us. You gotta let us know, and we could help you out. Okay, we're gonna give you some suggested practice, look at the quick checks, and then hopefully you'll be ready for that assessment. All right, but if you feel like you're good, hop on to the next video, and then we can get going there.